Okay class, let's get right to it. We're going to be doing an experiment with friction today. We will be pulling this load with this board and this bottle across the carpet, across the pipes, and across marbles, and we will be seeing which one has the most friction, okay? So we will be wanting to see which one has the most, which one has the least, and we will be looking at the coefficient of friction for each of these things, which we call mu. So if you notice here on the screen with me is the same thing that you see in the middle of your experiment page. You should have your experiment page with you and ready, and you should have the hypothesis section of it filled out where you chose either carpet, pipes, or marbles and your reason why you chose that to have the least amount of friction. So make sure you have that filled out, you have your paper, and we're just going to go ahead and get started here. So let's move this box out of the way. It's the box that you see in the middle of your paper. I'm going to bring in just one of those boxes at a time so it can be a little bit bigger on the screen here for our experiment purposes. So the first thing that we want to bring in is our carpet. Okay, that's what we will be doing our experiment on, and we want to go ahead and fill out the word carpet at the top of the box. The next thing that we need is R. In that box, the next blank that we see is R equals blank kilograms times 10 meters per second. And that kilograms is the mass of our object. R is our scientific weight, and we know our scientific weight from our notes is our mass times acceleration due to gravity. So if you notice here on the screen, it says scientific weight is newtons, and newtons is the mass in kilograms times 10, which is the acceleration due to gravity. So obviously we need to figure out the mass in kilograms. So we're going to use our scale here to figure out the mass in kilograms, and then we will be able to figure out what the scientific weight is, and that's what we need to use for R. Okay, so let's go ahead and get our pool scale turned on here. You can see I have it zeroed out. Oh, I did have it zeroed out. There, it's zeroed out, and I'm going to find okay, so we are finding the mass, and the mass of our load here is 4.03. Okay, and if we take that and just round it to the first decimal, it is 4.0, and when we, which is just 4, okay, and we know when we multiply 4 times 10, that's a really easy problem, no need for a calculator on that. 4 times 10 is 40, so we can go ahead and fill in that, and that gives us our R of 40, so fill in your R there. 40 newtons is our load weight. Our scientific weight is 40, okay? So that is the first step, and next we have to figure out our F. Our F is the force we need to put in. So we will be laying this down on our carpet, and we will be pulling forward to come up with our force that we need to put in. So we have our scale again zeroed out. I will hook it on here, and I will pull it as steady as I can to get a good reading of Alright, let's try a second pull. Here we go. And try a third one here. Okay. Our pull that time was 1.19, which we will round to 1.2. Okay, so our F is 1.2, and if we multiply that times 10, we get 12. So, because we're just moving that decimal over just one spot. So 1.2 kilograms times 10 equals 12. So you can go ahead and fill that in, and F equals 12. Okay, so now we have both our R and our F, and we know that from our notes our formula is mu equals F divided by R. Okay, so if mu equals F divided by R, all we have to do is take our 12 and divide it by 40, and that will give us our mu. That will give us our coefficient of static friction, because mu stands for coefficient of static friction. So we can go ahead and use our calculators to come up with what the mu is here. Because as I said, we are going to divide 12 by 40. So let's go ahead and do that on our calculator. 12 divided by 40 equals, and you can see we get 0.3. 0.3 is our coefficient of static friction, mu, for carpet. All right, so go ahead and fill that in. All right, while I get the board cleared off here on my screen, I'm going to wipe away carpet and the numbers from carpet, and then we will go ahead and get the second experiment set up. And the second experiment is going to be with pipes. Okay? So fill out pipes at the top of your second box there, and we'll bring in pipes, our pipe picture here, and we are going to go ahead and pull our second experiment, our load weight on the pipes. But if you notice, I did not clear away the 4, the 40, and the 40 because this load of ours does not change. That is what we call a constant in science experiments. You have to have a constant, and then you can only change one thing. So what we are changing is what we're pulling it on. That is the one thing we're changing. So let's go ahead. We will pull our second one to figure out what F is, what the force in is on the pipes. I have my scale zeroed out. And if you notice, that one is 0.13. That is a pretty big difference from our carpet that was 1.2. So 0.13, when we move the decimal point, we are going to get 1.3. So 0.13 kilograms times 10 is 1.3. So our F is 1.3. And just like last time, we will be dividing the force in by the load weight, or the R, okay, F divided by R, and that will be 1.3 divided by 40. And as I have said before, let's do that on our calculator. Okay, 1.3 divided by 40 gives us 0.03. Okay, so our coefficient of friction, our mu for on the pipes, is 0.03. Okay, that is a much smaller number than 0.3. So make sure you fill in your mu for the pipes of 0.03. All right, let's go ahead and get this one cleared off so that we can get set up for our marbles. I'm going to clear off our pipes and our numbers that we filled in there for F. And once again, I'm going to leave the numbers for R in there because it does not change. All right. And you can go ahead and get your word marbles filled in there. The last thing we will be testing is the marbles. And if you notice here, I have my circle full of marbles, and I'm going to lay my board right down on it. And we will be filling out the F. We will be finding the kilograms that it takes us to pull the board on the marbles to find out the coefficient of static friction of marbles. So you should have marbles filled out at the top of your third box. And again, we have 4, 40, and 40 already filled in because our load did not change. So we are ready to go ahead and find out how many kilograms it takes. If you notice, we're zeroed out there. We'll figure out how many kilograms it takes to pull this load on the marbles. Okay, let's do another pull. We were real close on that one. You don't have to pull real fast. On that one, we pulled, see if I can, there it goes, 0.35. So we have a 0.35, and if we multiply 0.35 times 10, we get 3.5. Okay, so again, this is much less than 12. However, it is actually more than our pipes. Okay, so let's take a look here. If we plug in 0.35 and we multiply that times 10, we get 3.5. So go ahead and fill in those boxes. So our F is 3.5. Okay, and if we do that division, on our calculator, we will do 3.5 divided by 40 equals 0.087. Okay, 0.087. We can round that up to 0.09. Okay, so we now have all three coefficients of friction. All right, so when we take a look at all three boxes across the way here, what we can see is that the carpet, we had 0.3. Okay, our coefficient of static friction was 0.3. On the pipes, our coefficient of static friction was 0.03. And on the marbles, our coefficient of static friction was 0.09. So we really discovered today that the coefficient of static friction of these three things, the one that is less is actually the middle one there, the pipes. Now I'm not sure what you chose for your hypothesis, but you will need to finish filling out the worksheet, the experiment worksheet, which one was the least, which one was the most. So the one that had the most friction was obviously the carpet. The one that had the least amount of friction was the pipes. And then I want you to tell me if you were right or if you were wrong about your hypothesis. And to maybe give you a little bit of explanation, if you chose marbles thinking that they would have the least amount of coefficient of static friction, the reason the pipe is the least is because when the pipe lays on the board, okay, it has just this one small line that it's touching the board and one small line that it's touching the floor. Okay, it's not rubbing on anything other than this line and this line. And it had the 3 pipes, so it had the 3 lines and 3 lines. When we look at the marbles, if you notice here in my hand, this marble, okay, this marble in the center is touching the board on the top and the carpet on the bottom. And that marble is also touching 1, 2, 3, 4, 5, 6 other marbles. So the surface area that is rubbing with the marbles is actually greater, okay, when it's rolling, than the surface area that is being touched on the pipe with the single spot. Okay, so marbles, what it comes down to when we're talking about friction is surface area that is rubbing against each other. If you remember the definition of friction, it was 2 surfaces that are holding together, and the surfaces that are holding together in each one of these things, obviously when the carpet, there was a whole bunch of surface area, like this whole bottom of the board was touching carpet, so there was a lot of surface that was touching each other, wanting to stick to each other. With the pipe, there was only the line and the line that were touching each other, wanting to stick. And with the marbles, there was not only the surface area between the board and the marbles and the carpet and the marbles, but also between the marbles themselves. So that surface area touching with the marbles caused it to have a greater coefficient of static friction. So the winner today of the least amount of static friction goes to the pipe. Alright, so go ahead and finish filling out your experiment worksheet. Make sure you take a picture and submit it for homework.